Yellowstone Supervolcano, how a 7-year USGS study showed an abnormal change has taken place in Yellowstone. This is by Callum Hoare on Express UK. Every so often we have news concerning what findings are new in this area. They're monitoring the supervolcano in every way possible. Scientists, alongside with the help of European Space Agency, the ESA, found that the caldera had fluctuated in height by up to 120 millimeters. This is what an unearthed report reveals. The 7-year study kicked off back in 1997. It was led by Charles Wicks and used satellite pictures snapped by the ERS-2 probe. Their research showed an upswelling of magma under the northern edge of the caldera near the Norris geyser basin, causing subsidence across the park. It means the caldera rim can rise while the floor sinks very closely to each other in time. Now we know that the Norris geyser basin, this was back in 1997 by the way, is where the Steamboat geyser is housed along with other geysers, such as the Ledge geyser, which has also risen in activity lately. Steamboat geyser has also already set a record surpassing last year's eruptions, which were phenomenal. They started in March, and I think there was over 32 last year, and we've already surpassed that this year, something which is very unusual. And it has to do with what is going on underneath the Norris geyser basin. It's rising. The surface appears to be in constant motion, rising and falling, but Dr. Wicks said the team needed more time to understand what is happening. He said in 2007, we need 10 to 20 years of research before we can get a feel for normal behavior. So he said this in 2007, it's already 2019, and they've had over 10 years. They've had over 12 years. And let's remember that the Yellowstone Volcano Observatory was only established in the year 2001. That was a little after the 2000 documentary by BBC on Yellowstone Supervolcano. It was so impressive, stressing the fact that another super eruption would be worldwide devastation, that it caused the U.S. government to give an order to open up the Yellowstone Volcano Observatory, and that was done immediately in the year 2001. So as we can understand, the observatory there is relatively new compared to other ones in the States and worldwide, and they have a tremendous amount of work to do to map everything, to find out what's going on. They have over 10,000 hydrothermal areas, and they know that Yellowstone contains over 60% of the world's geysers, including the biggest one, the Steamboat geyser. So, according to Dr. Wicks, he says we need 10 to 20 years of research to figure out what's going on, what is normal for Yellowstone as a supervolcano. He says then we can predict what's happening based on any abnormal behavior. He said, we propose that the observed patterns of uplift and subsidence result from the nearly continuous movement of molten basalt into and out of the Yellowstone volcanic system. Dr. Wicks and his colleagues believe that magma is rising from beneath the Sour Creek Dome in the caldera's eastern section, east. The Norris geyser is towards the west. So magma rising in the caldera's eastern section where it hits the solid mantle layer and then it spreads out. As magma pulses into the chamber under the dome swells and rises. Then when the magma pulse leaks out through fractures under the north rim of the caldera, the dome settles back. Now, okay, he says here that the magma leaks out through the fractures in the north. What does he mean by that? Where does it go to? Because it's not coming up to the surface. That's my question. He said, as the magma loses heat and cools, it drives back under the Mammoth hot springs. Right now, we're looking at a new episode of Uplift that started in 2004. Dr. Wicks is yet to provide an update on the situation since then. However, the discovery does not mean the supervolcano is any closer to erupting, despite claims that it is overdue. Researchers working for USGS stated that this theory couldn't be farther from the truth. In other words, they say that, all right, let's see. The website reads, first of all, one cannot present recurrent intervals based on only two values. It would be statistically meaningless. So that's why, of course, Wicks needs more information. But they go on to say, but for those who insist, let's do the arithmetic. The three episodes occurred 2.1 million, 1.3 million, and 0.64 million years ago. They're talking about the three most recent super eruptions, and the one that's 640,000 years ago actually was two eruptions, 150,000 years apart. They said, again, the last eruption was 0.64 million years ago. That's 640,000 years ago, implying that we are still about 90,000 years away from the time when we might consider calling Yellowstone overdue for another caldera-forming eruption. They're talking about a super eruption. Let's remember that we did have many other major eruptions at Yellowstone without them being super eruptions. We had one 130,000 years ago. We had one at 70,000 years ago. And since the 70,000 year eruption, we had 80 eruptions since that time, just basically every 6,000 years. And we're overdue for such an eruption, from what the geologist told us in a previous article. Not a super eruption, but a lava or a very strong hydrothermal eruptions. So, nevertheless, they say we cannot discount the possibility of another such eruption occurring sometime in the future, given Yellowstone's volcanic history and the continued presence of magma beneath the Yellowstone caldera. Now, he talks about the magma beneath it, but he forgets to say that there is a hot spot there, just like we have a hot spot in Hawaii, under Hawaii. The hot spot that feeds the eruptions in Hawaii, that has a chamber connecting Mauna Loa, Kilauea, and Loihi. They use the same chamber. And we have this hotspot here in Yellowstone, feeding the magma reservoir, which feeds the magma chamber. So that's a hotspot. It's not a simple magma chamber. It's a hotspot feeding it. Now, because it's a hotspot and a magma plume, it can do whatever it wants, basically, based on what happens in other areas of the world, like, for example, a very major earthquake, perhaps hitting somewhere that would shake the area of the hotspots around Yellowstone. We have no idea. But that's a possibility, because these are magma plumes, magma hotspots. They can do whatever they want, whenever they want to. And let's remember that Yellowstone many a time has had earthquake swarms from nearby earthquakes. As we said in previous videos, the 1999 Ridgecrest earthquake of 7.1, a few weeks later caused a quake swarm in Yellowstone. Same thing with the Alaska Denali earthquake. It caused a quake swarm at Yellowstone a couple of weeks later. So did the Haiti and the Chile earthquake. The Chile was 8.8 magnitude, caused a quake swarm at Yellowstone a couple of weeks later. So we see Yellowstone is very sensitive. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.